Okay, now we're on Unit 4A, or excuse me, 4C. And what we're doing, we're dealing with savings plans. For example, if you put so much money away every month, at the end of so many years, you're going to have some amount, you see. So A equals the accumulated balance. PMT is your payment, and we still have APR and the number N for the number of compoundings per year and Y for the number of years. So now, for question 1, we're given that the APR is 0.052 or 5.2%. The number of years is 1. I beg your pardon, the number of compoundings per year is 1. It's compounded annually. The number of years is 8, and the payment's $700. And by the way, here's our formula, and this formula is on page 228. So if you're having trouble reading my writing, please go to page 228 and you'll find it. So installing the appropriate values in the formula, we have 700 times the associated quantity divided by our interest rate over 1, n equals 1. And what we get when we compute that is $6,732.38. Now we're going to do it again. Same formula, except this time we're talking about a 7% interest rate. We're compounding monthly, so n is 12. The payment's $160, and the years are 17. And when we install those values in our formula and compute, we wind up with $62,420.19. Let me double check that 19 to make sure I have it right, and I'm sure I do, but it's hard to read my writing there. And so here we're taking a look at it. Yeah, 19 cents. Okay, let's go on to question 3. And this time we're given 2 people, Brandy and Stephen. And for Brandy, the payment's $75 a month. Her interest rate is 7%. She's compounding monthly, and it's for 10 years. And when you install the values into the appropriate positions in the formula, you get that Brandy's balance at the end of 10 years is $12,981.36. For Stephen, his payment is $225 a month. So, excuse me, not a month, a quarter, because he's making payments quarterly, which is, if you were going to do it monthly, which would be $75 a month, but he's doing it quarterly. His interest rate's greater, it's 7.1%. The years are still 10, and when you install the values in the appropriate positions and compute, you get $12,946.86. And so it turns out by compounding monthly instead of quarterly, Brandy had a higher balance at the end of 10 years. So now on to question 4. And in this case, what we're solving for is the payment. So we take the same formula, we multiply both sides by the reciprocal of the quotient we have in the original formula, and that way we isolate payment, and then it's just a matter of installing the values in their appropriate places. So the amount is $145,000, The years are 15. It's 9.3% interest, and the number of years is 12, and so the payment equals, in installing the values in appropriate positions, we come up with a payment of $372.93. So if you made that payment for 15 years, you would have an accumulated balance of $145,000. And we'll stop here and go on to part 2.